Example 14.4, farm to table. So please take a moment, pause the recording, and read over the example to make sure you understand how all the calculations were done. Okay, now take a moment and calculate and report the 90% confidence interval for the population proportion of all U.S. adults in 2018 who try to include locally grown foods in their diet. And there it is. We're going to take that. It's the exact same calculation. The only thing that you should change is that coefficient here, that Z star. As we're multiplying by a smaller number, we would expect this interval to be narrower, and it certainly looks narrower. Instead of going to 0.708, this only goes to 0.712. Now, what are the midpoints of these two confidence intervals, the 90 and the 95%? What do you notice? Well, we know the midpoint, first of all, you don't even have to do the calculation. The midpoint has to be the 0.73 because that's where you start and you add and subtract the exact same value from both sides of it. But how would I figure out if I want to calculate it? I would take the average. I would take 0.712 plus 0.749 divide by 2. And that's what I did down here. And I ended up with 0.73, and that's what I should get, right? Because that's where we start the calculation. The center is that p hat. Now, determine the widths of both the 90 and 95% confidence intervals, and what do you notice? The width is just how broad it is, so it's that range of values. So instead of adding and divided by 2, we're just going to take the difference between, and for the 90%, the 0.749 and 0.712. Once again, please take a moment and calculate both those widths and come back and check your answer. And there they are. Now for part D, it said determine the half widths of the 90% and 95% confidence intervals, then rewrite each interval in the form of static plus or minus margin of error. So I'm going to do it specifically for the 90%, get that started. The half width is going to be the width divided by 2, and I get 0.0185. Then to rewrite it for that 90% confidence interval, we're going to start with the statistic, which is p hat, and then we're going to do plus or minus that margin of error. We actually have calculated this, and I'll show you in just a moment. This right here is called the margin of error, this value here. Please do the same thing for the 95% confidence interval, and then come back and check your answer. So what we found is that margin of error. In fact, we don't have to do all the steps that we just did to calculate what this margin of error is. We're calculating automatically when we find the confidence interval. So the margin of error is how researchers report how much variability they anticipate in the estimated numeric value of the parameter based on the sample size and how confident they want to be. When estimating a population proportion, the margin of error is that Z star times the square root of p hat, 1 minus p hat over n. Okay, so now you know how to calculate the margin of error directly. You can see that, but we did work our way to show that that's how we could get there. Now, true or false? Increasing the confidence level increases the margin of error. So if we get more confident, what happens to Z star? Does it get wider? Does it get bigger or smaller? And hopefully you think, oh, it gets bigger. So this is true because our Z star gets bigger, so we're multiplying by a larger number. As the sample proportion gets larger or smaller, the margin of error increases. Now this one's a little tricky, and I'm going to tell you it's false. Okay, what's going to happen is when they say it gets larger or smaller, they're talking about from the absolute most conservative, which is 0.5. So as we move away from 0.5, it actually gets larger. It doesn't get larger, it gets smaller. So as p hat moves away from 0.5, the margin of error decreases. And why does this make sense? Well, we're moving away from that 50-50 split. Okay, so if you want to convince yourself, calculate a z star times p hat, 1 minus p hat, all over n. Choose, let's say, n to be 1,000, and do it with p hat equals 0.5, and then do p hat equals 0. Let's say 3, and you will see, and choose a z star, any of the z stars you want. But you'll see that what happens to this value as you move away from the most conservative, the 50-50, that it will get smaller. As the sample size increases, the margin of error decreases. Well, this is true because remember, as this number gets larger, you're dividing by a larger number, which makes this whole thing smaller. So this is true.